Hey guys, it's Miss Johnson, and I am here to bring you our video for Unit 2 Notes 4, Solving Systems by Elimination. So we just talked about solving systems by graphing and solving systems using substitution. Today we're going to talk about solving systems using elimination. So here's our steps. Now the thing about elimination, that word is very telling. Elimination tells you that you're obviously trying to get rid of something or eliminate something. So what we're trying to do is eliminate one of our variables. So if I look at my steps, the first thing I want to do is add my two equations together, and one of the variables should cancel out. So that would be my first step. And then the second step is solve for whatever variable is left after that variable eliminates out. And then the last step is to substitute that thing that you found back into one of your equations and find the other variable. So let's take a look at what this looks like. Remember that you can pause the video to write down if you need a little bit more time. The first question, number 1, I have x plus 2y is equal to 10 and negative x minus y is equal to negative 6. So the first thing I want to do is I want to add my equations together. So when I add these two equations together, this is what happens. I combine my like terms all the way across. So combining my like terms, 1x minus 1x makes my x's drop out. That's a positive x and a negative x, so my x's go away. When I combine, leaving me with 0x. When I combine my y terms, 2y minus y is 1y, and then 10 minus 6 is 4. So what happens here is my x term is gone. It went away. I don't need to represent 0x because it doesn't mean anything. So I'm left with just 1y equals 4. And the last thing I would do is divide by the 1, which we all know doesn't change our answer, and I get y equals 4. So my x variable dropped out, leaving me with only one variable, which is how I can solve for what's left over. Now I need to go back and get x. So I'm going to go back to the original question, and I'm going to plug this 4 in for y. I'll just pick the top one. It doesn't matter which equation you pick because it's a solution to both. So I'm going to plug it into the top one. And I end up with x equaling 2. So then when I write this out as a solution, it looks like 2 comma 4. And there we are. So let's take a look at number 2. In number 2, I have my x's lined up, I have my y's lined up, I have my constants lined up. That's an important piece of elimination, by the way, is that all of your terms are lined up. Notice that these equations are in standard form, x and y together on the left and the constant over there on its own on the right. So when I line these two up, add them together, negative 2x minus 3x is going to be negative 1x, or just negative x, and then positive y and negative y drop out. That adds to be 0y, and 0y we don't need. And then the constants over on the right, 4 minus 8 is negative 4. So then the next thing I would do is divide by that negative 1 to get x by itself, and I get x is equal to positive 4. Now I need to plug that back in to get my y variable. Again, I'll just pick the top equation. It does not matter which one you pick. So 2 times 4 plus y is equal to 4. That's 8 plus y is equal to 4, and y is equal to negative 4 when I subtract the 8 there. So then I write out my solution, and I have a 4, negative 4. All right, let's try number 3. In number 3, when I add my two equations together, I notice that the x terms are lined up, the y terms are lined up, the equal signs are lined up, the constants are lined up. That's important to have before we try to eliminate. Now, my negative 2x and positive 2x drop out. So that's what happens there. Then I'm left with the y's. 3y and 2y is 5y. And over here, negative 11 plus 6 is negative 5. So I'm dividing by 5 here, and I have negative 5 divided by 5, which is negative 1. And then the next thing I need to do is plug that back in to get my x. I'm going to pick the bottom equation this time, so I have 2 times negative, oops, sorry, my x is what I need to know. So it's 2x, oops, 2x plus 2 times negative 1 equals 6. That's 2x minus 2 is equal to 6. Add the 2 to both sides, that's 2x equals 8. and divide by 2, I get x equals 4. So my solution here is 4 comma negative 1. Over here in number 4, I need to add my like terms together. I have x's lined up, y's lined up, equal signs lined up, constants lined up. All things are in the right order, so that's good. When I add them up, 1x plus 7x gives me 8x. And then negative y and positive y drops out. So that's what allows me to solve this because my y variable went away. 9 and 7 is 16. Divide by 8. And I'm left with x is equal to 2. Okay, so y variable dropped out. I was only left with x. I can solve for one variable, so I finished that out. Now I need to go back and find the y variable, so I'm going to plug it in. I'll just use the top equation. We can pick either one, but I'll use the top. So I have 2 minus y is equal to 9. Subtract the 2, and I get negative y is equal to 7, and then divide by negative 1, and I get y is equal to negative 7. So if I write this out as a solution, it's 2 comma negative 7. All right, so let's take a look at number 5. In number 5, I have an x minus y is equal to 9 and negative 7x minus y is equal to negative 7. Okay, so now there's something that's a little bit different in this equation. I notice that my y variables both have 1s for coefficient, but they're also both negative. Now that's not going to work. That's not going to make them drop out because if I add these together, I get a negative 2y. So what happens here is I need to multiply one of these equations by negative 1. And that goes through the whole equation, all three terms, and that gives me a positive 7x, a positive y, and a positive 7 on the other side. Now the top equation I kept the same, so I'll just rewrite that down here. And now I can add these together. So by multiplying through by that negative 1, I now have opposite coefficients that are going to drop out when I add them up because negative y and positive y is 0y, and that's what I need. That's what I want. So when I add these, 7x plus 1x is 8x. The y's go away. 7 and 9 is 16. Divide both by 8, and I end up with x equals 2. If I plug that back in, I'll just plug it into the top equation. I have 2 minus y equals 9. Subtract the 2, negative y equals 7, and divide by negative 1. So I have y is equal to negative 7. Now I want you to look at this question compared to the question in number 4. If you take a look at number 4, we ended up with the same answer. We ended up with 2 comma negative 7. And if you look at the system started out looking different. But once we multiplied through by that negative 1, it ended up looking exactly the same as the system in number 4. So that goes to show you that you can multiply an equation by a constant, by a coefficient out front, to give it a different leading coefficient as long as you go all the way throughout the whole thing. Notice I went across the equal sign as well. Now let's try that again in number 6. I have negative 4x plus 2y is equal to 8 and negative 4x plus 3y is equal to 10. Now again, I notice that I have a negative 4x and a negative 4x. Now that's a good start, but they need to be opposites. They're both negative right now. I need one of them to be positive. So I'm going to take the top equation and multiply it by negative 1 so that that changes all three of those terms on the top. So now my top equation looks like this. Positive 4x minus 2y is equal to negative 8. Bottom equation stays the same. I haven't changed it. And then I add them up. Because now when I add them up, 4x and negative 4x is 0. That drops out, which is my goal. The negative 2y plus 3y is just y, because negative 2 plus 3 is just 1. And negative 8 and 10 is positive 2. So I'm left with y equals 2. I have no division to do, so I'm good. Now let's go back and find the x term. So I have negative 4x plus 2 times 2 is equal to 8. Notice that I'm using the original equation, or I could have used the original bottom equation, or I could have even used the change equation up here. It does not matter. So negative 4x plus 4 equals 8. Subtract the 4. Negative 4x equals 4, and divide by negative 4, and I get x equals negative 1. So when I write out the solution here, I have a negative 1 comma 2. All right, let's flip to the next page. The next page starts off with a word problem. It says the sum of two numbers is 12, and the difference of the same two numbers is -4. Find the two numbers. Now, you're given the situation in a sentence, but you need to write a system in order to solve it. So we're looking for two numbers. I'm just going to call them x and y. So the first sentence that I notice or that I see is the sum, which tells me I'm adding, of two numbers, which I said was x and y, is means equals and 12. So that looks like x plus y equals 12. Then the second question, difference, tells me I'm subtracting. Same two numbers, x and y, is equals -4. So x minus y equals -4. All right, that's the system that I need to solve. Now I need to go ahead and add these together as long as I have opposite coefficients. Here I have 1x and 1x, but there I have positive y and negative y, so I'm ready to add them up because positive 1y, negative 1y, when I add them together, I end up with 0y, which cancels those out. So 1x and 1x is 2x. 12 minus 4 is 8. Divide by 2, and I get x equals 4. Then I need to go back and find the other number. So I plug that in. I'll have 4 plus y equals 12. I just picked the top equation. It doesn't matter. Subtract the 4. Y is equal to 8. So the two numbers are 4 and 8. All right, now this was all fine and dandy when we had coefficients that were the same number. As long as we made one of them positive and one of them negative, then we were good. But what happens when we have coefficients that aren't the same number? Sometimes we need to do a little bit of manipulation. So the first thing that we need to make sure of is that both equations are in standard form. And then the second thing we need to make sure of is that we multiply one, or sometimes we need to multiply both, so that one variable has opposite coefficients. That's what we need, opposite coefficients. For example, 3 and -3. One needs to be positive, one needs to be negative, and they need to be the same number. Then the rest of the steps are the same as what we saw on the front. Add the two equations together, solve for the remaining variable, substitute that variable into the other one. So these are the same as the front side. Okay. So let's do a few more examples. The next set, number 1, I have x plus 2y equals 10 and x plus y equals 6. They're both in standard form, so that's good. X, y, equal sign, constant. But I need opposite coefficients. Now I notice that my x coefficients are both 1, so that's pretty easy. That's going to be similar to the front where I just need to multiply by -1 to change that. I'm choosing the bottom equation. It doesn't matter which one you pick. You just need one to be positive and one to be negative. So the top's going to stay the same. 1x plus 2y equals 10. Bottom is now -1x plus, or I'm sorry, minus y equals -6, because remember that -1 needs to go to all three parts of the equation. Now I can add them up, and my x terms drop out. 1 and -1 is 0. So 2 minus 1 is 1y. And 10 minus 6 is 4, so I have y is equal to 4. Then I plug that back in. X plus 2 times 4 is equal to 10. That's x plus 8 equals 10. Subtract the 8, and I get x is equal to 2. So my point here, or my solution here, is 2 comma 4. Now let's take a look at number 2. I have 4x plus 2y is equal to 8, and 3x plus y is equal to 8. So I don't have coefficients of the same number. That's a problem. I need to fix that. And I don't have coefficients that are opposites, so I need to fix that as well. I do notice, however, my eye is drawn to this y right here because it has a 1 coefficient. Anytime you have a 1 for a coefficient, that makes it really easy to change. So to make it opposite from the other equation, I need to multiply by -2. So that's what I'm going to do. I'm going to multiply the whole equation by -2. Just on the bottom. The top equation is going to stay the same. The bottom equation is now going to look like this. -6x minus 2y equals negative 16. Now I can add them up because now my y terms are 2 and negative 2 and they drop out. Then when I add my x terms, 4 minus 6 is negative 2x, 8 minus 16 is negative 8, and divide by that negative 2, cancel that. So x is equal to positive 4. Then I need to go back and get y, so I'm going to just plug it into the top equation. 4 times 4 plus 2y equals 8. That's 16 plus 2y equals 8. That's 2y equals negative 8 after I subtract the 16. And then divide by 2, and I get y is equal to negative 4. So my solution here is 4 comma negative 4. All right, number 3. In number 3, we have the system 2x minus 3y is equal to 11 and 10x plus 2y is equal to 30. So no coefficients that are the same. They're already in standard form, so that's helpful. But my coefficients aren't the same and they aren't opposites. But what I do notice is that I can multiply this top equation by negative 5 because that'll give me a negative 10x, which will be opposite from the 10x that's below it. So that's what I'm going to do. So I have negative 10x plus 15y, because negative times negative is positive, and then equals negative 55. Bottom equation stays the same, and then I add them up. My x terms drop out. 15 and 10 gives me 25y, and then negative 55 and 30 is negative 25. When I divide by 25, I get y is equal to negative 1. Plug it back in to get x, so I have 2x minus 3 times negative 1 equals 11. That's 2x plus 3 equals 11. Subtracting the 3, I get 2x is equal to 8, and dividing by 2, I get x is equal to 4. So my solution looks like 4, negative 1. Number 5, no opposite coefficients, but my equations are in standard form, so that's helpful. I notice that my y terms, I have a negative 4 and a negative 12. I can easily multiply this negative 4 by 3 to get me to 12, but I need to multiply it by negative 3 so that it goes to positive 12, being the opposite of that negative 12. So that's what I'm going to do. Negative 3 goes throughout the whole top equation. That gives me negative 15x plus 12y equals negative 90. Bottom equation, 12x minus 12y equals positive 96. Add them up. The y terms drop. I have negative 15x and 12x, that's negative 3x. Negative 90 and 96 is positive 6. Divide by negative 3. X is equal to negative 2. Plugging that back in, 5 times negative 2 minus 4y equals 30. That's negative 10 minus 4y equals 30. That's negative 4y equals 40 once I add 10 to both sides. And then dividing by negative 4, I get y is equal to negative 10. So my solution looks like negative 2 comma negative 10 for x and y there. Couple more, top of the last page. We have 10m plus 5n is equal to 5, and 3m minus 3n is equal to 24. Okay, so now we don't have any terms that are opposites, and we don't even have any terms that can be easily multiplied. So what I'm going to do is I need to multiply both equations. That's a bummer, but it happens. Okay, so I'm going to choose to get rid of the ends or eliminate the ends because I already noticed that one is positive and one's negative. So that makes life a little bit easier. The top equation I'm going to multiply by 3. And the bottom equation I'm going to multiply by 5 because what that does is give me a 15n and a negative 15n, and those will drop out. So 3 goes through the whole top equation. 30m plus 15n is equal to 15. And then the bottom one will be 15m minus 15n is equal to 5 times 24 is 120. Now I can add those up because now n's go away. 30 and 15 is 45. So 45m and 120 plus 15 is 135. Divide by 45, and I get m is equal to 3. Then I have 10 times 3 plus 5n is equal to 5. That's 30 plus 5n is equal to 5. That's 5n is equal to negative 25 because 5 minus 30. And then n is going to be negative 5. So 3 comma negative 5. I still go in alphabetical order there even though it's not x and y. One more time, in number 6, I have 14x plus 21y is 14, and 3x minus 9y is negative 51. I need to multiply both of these. I'm going to choose again to eliminate the y's because one's positive and one's negative. So I'm going to multiply this top one by 9 and the bottom equation by 21 because that's going to give me opposite coefficients. When I do that, distribute all the way through, I get 9 times 14 is 126x. 9 times 21 is 189y. And 9 times 14 is 126 again. On the bottom, 21 times 3 is 63x. 21 times negative 9 is negative 189y. And 21 times negative 51, holy cow, negative 1,071. So I got some big numbers here, but that doesn't mean I can't do it. All right, so y terms, opposite, positive 189, negative 189. That was my goal. That's why I did what I did. Then add them up. 126 and 63 is 189. So I have 189x, and then 126 minus 1,071 is negative 945. Divide by 189, and I get x is equal to negative 5. Okay, so now I plug that x back in and I get 14 times negative 5 plus 21y is equal to 14. That is negative 70 plus 21y equals 14. Add the 70 to both sides and I get 21y equals 84, and then y is equal to 4. So my solution there is negative 5 comma 4. Holy cow. Word problems at the end. I think I'm going to stop our video there and I'll do another short video with our 3 word problems that are at the end. Thanks for listening and I'll come back in just a little bit.